Alright, hello everyone, welcome back. So in today's class, we can talk about transformer and BERT for you. This is also the last part of the deep learning for dealing with text data in this section. So in this class, we plan to discuss the detailed information for the transformer model and how this model can achieve very good performance in dealing with many natural language processing and data and tasks. So the transformer and BERT, they are initially proposed for the natural language problems, and nowadays the researchers also try to extend these models to deal with some other data like images and graph data as well. So they can achieve very good performance in many of the tasks in natural language processing, in computer vision, and they are all the newest and also state-of-the-art models achieve the best performance in many tasks. So the transformer and the BERT, they have received lots of attention nowadays, and we can talk about what are the detailed architecture in these models and how they achieve very good performance. And here is the outline for today's talk. In the very beginning, we can discuss a very important concept in deep learning. It's called attention. We will discuss what is attention used in deep learning and how to use this attention to build a model architecture. After that, we have an open question. Before we have been introducing this recurrent neural nets, we mentioned that to capture the sequential patterns in the input data, we have to build a sequence model, right, like recurrent neural nets, to capture these patterns. Then we have an open question, as shown here. Do we really need to use the sequential models or not? Is it important to capture these sequential patterns in learning the representation for the words in documents? This is an open question. According to our previous discussion, we mentioned that this is important. Then we propose this question again here. Is it necessary or not? We can provide you with more discussion in this talk as well. After that, we can talk about the transformer model with attention, and we will discuss in details about the transformer architecture covering the safe attention as well as the multi-head safe attention based encoder. And we also talk about how to use these encoders to build a very deep transformer model, by stacking them on top of each other and for learning. So the transformer can be used extensively, and at the end, we also try to discuss a very important model based on transformer. It's called BERT. This BERT utilizes both the transfer learning and pre-training for build a transformer model with some data sources, and then can further transfer it to some other tasks instead. We will discuss what is BERT and how to do the transfer learning and also do the pre-training with BERT on some other tasks in this talk. Okay, so first of all, let's talk about what is attention in deep learning. So we as human beings, when we read the images or we read the articles, normally we need to pay attention to specific regions when we read, right? So in this page, we show you with some examples. We show you with the pictures of a dog and also an elephant. At the bottom part, we also show you with a piece of article. And when we read these images or the articles, normally we will pay attention to different regions. For example, for the dog, we will pay more attention to the face of the dog to see what category of this dog is, and also the color of the dog and some other facial expression of the dog. It is similar for the elephant. When we see animals, normally we prefer to see the face of the animal, also look at the eyes of the animals, right, to see what they are thinking and also their emotion, right. So therefore, you can see for both the dog as well as for the elephant, and we pay more attention to the face of the animals and also see the eyes, be focused on them, right. So this is the way we read the images. How about the article that we show at the bottom? When we read a piece of document or article, normally we will pay more attention to the numbers inside them, right? Also some specific region of the numbers in them. As shown at the bottom, we highlight some regions where which are designed with higher attention scores actually when we read these articles. We see that most of them, they are related to the numbers actually. According to the highlights, we find that most of these highlighted regions, they are about the numbers actually. In other words, we pay more attention to the numbers in reading, to capture the information inside these articles. So this is the way we pay attention to read images, also the articles. Actually, in the real world, different people will pay different attention to different parts. In this page, we show you with the image about which is taken during the Oscar, if I remember correctly, in the previous years, right? And I downloaded this image from Twitter, and also it shows it is a selfie of several movie stars, and probably you know them much better than me. I only know a few number of them. In this picture, I only remember this guy. I remember. He actually. He's from the House of Cards, right? This kind of TV show actually. And for the remaining, you can also check. If you know them or not. So given the same image, when we look at the images, different people will pay attention to different regions or different parts of the image. In this page, we show you the attention scores, from the women and also from the men's perspective. Given the same image, actually the women, they will pay more attention to the central part, to this lady, and also to some other people in this image, right? However, when it comes to the man, actually this man will pay more attention to this guy. I'm not sure why, right? I'm not sure why. Also, the man will also pay attention to this lady as well. So, I mean, this is very interesting. Different people will pay attention to different regions, and you can also check by yourself which region you pay more attention to, actually. Okay, so this is attention for the human beings, right? We normally pay attention to different parts in readings, right? When it comes to the machine learning model or deep learning models, can we also capture this kind of attention in learning? So actually in deep learning, we also have this concept of attention, which is used to weight different regions inside its input data. So in the English, the word attention denotes our focus on something and also take greater notice to something, right? And either do some activities or in learning. And when it comes to the deep learning, this attention is a concept, also a component in a deep learning model architecture. It is used to in charge of managing, also quantify the interdependence, different parts, either about the hidden representation or about the inputs. So the attention can be used in different parts in the model architecture, either between the input and output layers. It can assign higher weight for some inputs and for calculating the outputs, and it is also called general attention. Besides this one, we can also assign the attention for the within the input elements instead. Given the input elements, which one will be more important, and we can assign them with a high attention score. For measure their importance, right? It is also called safe attention, and this safe attention will be calculated purely based on the inputs instead. In the talk, we can discuss what is safe attention in the following part for design a transformer model, and we can also calculate this attention scores with some examples. At the bottom part, we show you with a toy example given 4 words. We are doing translation here. How was your day, right? These are the inputs. And by some models, we can learn the hidden representation of these input words, right, as these embedding vectors. And here we are starting the translation of the sentence from English properly to French, right? I cannot recognize these words, in which language. So when we do the translation, given the whole piece of sentence as input, we will decide the translation results by the content inside the input, right? However, different kinds of words in the input will play a different role in translating different results, right? Now, when we translate how was your day, this sentence from English to another language, and we have to generate this translation result, word by word, right? And when we translate the first word, we find that the first word how actually plays a higher role. And this kind of denoting the importance scores, or the weight scores for different words in the inputs. We have 4 inputs, and there we have 4 attention scores as shown here. So when we translate the first word, in the result, we find that the first word in the input will have a higher weight, and then we come to the second one, right? And when we translate the second word as a result, we find that the second word has a higher weight. Then we have the first one. And it will be similar for the third word. If we translate the third word, the second word also of the words also have a higher weight than the other entries, right? And so forth for the remaining. The third word and the fourth word we have a higher weight instead. You find that when we do the translation, different word in the input we have different weights in translation the inputs to the results, right? And it is also called safe attention actually. We can discuss how to calculate this attention scores in the following part based on the inputs purely, and then we can further know how this attention score we have generate the results in the translations. Okay, so this attention score used in deep learning. We can discuss more detail about this kind of thing in the transformer model in the following part.